Alright, now we are going to be looking at the parallel of vectors. And please ensure you focus, avoid distraction, very important. And please ensure you subscribe, it's very important, so ensure it's free. So that you will understand that you are going to do in this place today. Focus, don't distract yourself. So let's start. What is the meaning of this parallel law first? Okay, let's state it. Let's state it and see what we're going to have. Now, parallel law of vectors states that if two vectors, 2TWO2, if two, not three, if two vectors are represented in magnitude and direction, if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, then the resultant of this vector will be represented by a diagonal in magnitude and in direction drawn from their point of intersection. Drawn from what? Their point of intersection. Look at what I'm going to say. We said if two vectors are represented in magnitude and direction by the two adjacent sides, look at the parallelogram like this. So we call the parallelogram something like this. This is a parallelogram. So I'm going to tell you that if two vectors, this side same thing as this side, this side same thing as this. So if I'm telling you if two vectors are represented in magnitude, remember the length of the line denotes the magnitude, the direction should be an arrowhead. When I say if two vectors, this and this now, represent the magnitude and direction. Direction means this one going from here to this place, and both of them are going from their starting point. They are going away from their starting point by the two adjacent sides and this. If you call this one vector, let's say the first vector 1 and the second vector 2, F1, F2. By the adjacent sides of the parallelogram, you also say A, B. There's no problem about that. Then the resultant of the, so if you add this to this one like that, the resultant means the total you're going to have. The total you're going to have, if you add this one to this now, or the force that will balance this infinite of these two forces will be a line drawn from the point of the intersection, which is a diagonal. Let's just draw it. Let's from here to this place. So in magnitude as well as direction, so something like this. So you have magnitude is from there to here, and direction is still going away from the starting point. So this will be the resultant, or the inverse of this and this will be equal to this. Like that. So that is the resultant, or the total force we're going to have. Then, now, this is just the statement. So if I ask you now, how do you actually solve this? You must know something, which is the angle between these two vectors. Vector F1 and then let's say the angle theta. You know that those two angles are very, very important. Very important. Then, let's look at this. If I ask you what is the value for R, how do you calculate R? The magnitude of R will be equal to the square root of the first vector, you square it, the second vector, you square it, plus 2 times the first vector, the second vector, and times cosine this angle between them. That's how we do it. Cosine of this angle between them. Very important. So the time can also come, you ask you to look for this angle. Let's see, let's for this angle alpha, and all this other angle beta. Remember this one is F1, this one is F1, this one is F2, this one is F2, and this is F2. So you can either ask to look for the resultant angle between the resultant and F1, or angle between the resultant and F2. You can also look for those angles. How are you going to do it? So you have to look for those angles. Let's say this is the resultant. This is the resultant we have in here. This is the resultant we have. This is the resultant we have. And this is our F1. This is our F2. This is our F1. This is our F2. That's it. Then these are resultants. And this is the angle between F2 and resultant, which is alpha. Then beta is the angle between F1 and resultant. I'm just trying to draw this triangle in this place. I'm just transferring this place, half of it. Just half of the full diagram. I just divide it by 2 and move to this place. So ensure you're on toss. So there's something you should know in this place. We'll do some geometry. We'll do some geometry. But I'll something like this. I'll something like this. I'll do something like this. Remember? Something like this. This is what I'm having. You see this and this. So if I say try is theta, here will be 180 minus theta. We'll use some geometry. If I say this is theta, so the 180 minus theta will be rules of geometry. So all this angle will be, because you should also know that angle is still important. Still very, very important. So if from here to here is theta, then this other angle here will be 180 minus theta. That's what I'm going to have. So this angle now will be 180 minus theta. 180 minus theta. Can I ask you now, what is the any of the internal angles there? What is either this or that? So another way to also run this would be use what we call the sine rule. Sine rule, which is you take the resultant or you take any of the forces there. You can take forces, you can take any of them. So let's start from resultant. Let's start from resultant, or let's start from F1. You take F1 divided by the sine of the angle that is directly opposite to that F1. So which angle is facing this F1? This alpha, look at it, is facing the F1. So take the sine of the angle and equate it to F2 over which angle is facing F2? Look at it. Beta is facing F2. So over sine of that beta is equals to, then let's take resultant now, over which angle is facing resultant? 180. Okay, take the sine, the angle sine 180 minus theta. So this one you will have from your sine. So if I ask you what is alpha, what's alpha? You should know F1 and resultant or any of them. If you just have maybe you want to solve this and this, you can just solve it in two. So you can either have this and this or this and this or this and this. You can also I say what is theta now? I bring out theta. I say what is alpha? I bring out alpha. I say what is beta? I bring out beta there. So you can also use this one to obtain answers from this place. So just remember we transfer this place half of the diagram. Run out this. So this one is sine rule. That's sine rule. We also use it to obtain. Use sine rule to obtain the internal angles and the sides of something like a triangle that is oblique. Oblique triangle. That's a triangle that is not a right-angled triangle. So also use sine rule to obtain the length of the sides in mathematics. It's still very, very important. This one is still function where we go to mathematics, especially what they call. We also use it in theory. It's very, very important. Very, very important. So take note of that. Take note of this rule. Remember how we got this. This over the angle facing it. This is a triangle. It works for any triangle at all. Let's have this triangle now. Let's have alpha, beta, there's a theta. So let's say A, B, C. Okay, sine of this over this will be equal to. Now let me also teach another thing, very important thing. Now this can also be just having F1 over this. You can have it as move everything here up, bring everything up down. It can also be sine alpha over F1 equal to sine beta over F2 equal to sine y minus theta over I. It's still valid. Very, very valid. It's still very, very valid that way. This is the same thing. So for all those I just say A over sine beta is equal to what? B over sine beta is equal to what? C over sine alpha. Just like it works for all triangles that are oblique triangles. So please take note that it's very, very important. So let's look at another case now. Let's have a case in which we have two forces. One is coming in to the starting point, the other one is leaving the starting point. So what will be the resultant of these two forces? How do you calculate the result of these two forces? And let's say the angle we're given was this, theta. So how do we calculate the result? So let's go this one, F1, let's go this one, F2. So the other one will be this. That will be the resultant of these two forces. That will be the resultant. It will be the resultant of these two forces. And in order to get that resultant, it should be equal to this same formula, which is the F1, square it, or the F2, square it. But this plus for this other one, this place now, if both of them are leaving this starting point, and you're looking for the angle between them, and look at this angle between them. This one is leaving the starting point, leaving the starting point, use plus here. But if one of them is coming towards the starting point, the other one is leaving the starting point, the resultant will be this, or this other will be minus 2 f1 f2 cos theta. That's how you do something. This is the theta that we want. Please take note of that. It's very, very important. Very, very important. That's why you see this formula in some cases. Check this one very well. It's not that this direction of this resultant, this direction of this other one, this direction of this one. So if you check this point, it's not that one is coming into this point and one is leaving. So if you want to use this one, it's minus theta, check some formulas. You put one it's minus theta here, you put minus in this place. Because this direction is coming in, another one is leaving. So if you want to use another theta, in which this one is leaving, this one is also leaving, use plus. But if you want to use the one in which one is leaving, the other one is coming in, you want to use this theta here, which is something like this one. This one is coming in, this one is leaving. You want to use the theta between them, this one will be taking a negative sign. So please take note of that. It's very, very important. But in a very short or in a not shape, a very good way, or I think in the shortcut, very good shortcut. So when we use parallelogram law for forces to add up vectors, now this one will only work for vector quantities only. It will not work for scalar quantities because it's a law of vectors quantities. We use to utilize another law of vector addition. We use to add vectors together. And how many vectors do you use to add? Actually, 2 vectors. Because if 2 vectors are represented, you take note of that. It's not as hard as you think. This is not hard at all. So please, let's try this question. Let's say, obtain the resultant of 2 vectors. Obtain the resultant of 2 vectors acting away from a point. Acting away from a point. Acting away from a point. And induce an angle of 30 degrees with each other. And induce the angle of 30 degrees with each other. If their magnitudes are 5 meters and 7 meters respectively. If their magnitudes are 5 meters and 7 meters. So one of the things that is meter that is another is displacement. Displacement is meter and is a vector quantity. So this one is displacing 5 and displacing 7, both of them are from the same point. So what's the total of these 2 vectors? How do you do that? So remember, they're acting away from a point. If they're acting away from a point, and it's an angle between them, to use this one. If one is acting away from the point, another one is acting towards that point, then this one matches to minus. So look at what I have to play. Something like this. So it's acting away. I call this one 5 meters. So it's acting away as well. I call this one 7 meters, and the angle is what? 30 degrees. So what's now the resultant of those 2 vectors? Remember, from this formula, this will work there. So this will work there. So we're going to be having 5 squared plus 7 squared plus 2 times 5 times 7, because the angle between 5 and 7 is what? 30 degrees. So what I'm going to have here. So without wasting time, using our calculator to run this, you are going to have 11.6 meters. That is the resultant based on this law of vectors. And the result of both of them. So let's look at another question. Look at another question under these vectors. Vector is not actually that difficult. That is not very, very difficult. Although you can also ask to look for the direction of the resultant. Although we are not looking at that actually per se now. I just will try to calculate the magnitudes of the resultant. So let's try this. Let's see question 2. Obtain the resultant. From the diagram below, obtain the resultant of the vectors shown. The diagram below, obtain the resultant of the vectors shown. The diagram below, obtain the resultant of the vectors shown. So first one, we have something like this. Something like this. It's 2 newtons. It's 3 newtons. 2 newtons, and we have a 40 degree. Then B, this is we have something like this. this 2 newtons, this 4 newtons, and this angle is 20 degrees. Will be the resultant. You see how it's like this. Then have it something like this. So the angle is 110 degrees. So let's say 26 newtons. And this one is 8 newtons. Let's say 24 newtons will be a resultant. Will be a resultant actually. So you can decide to use, okay, there's no problem. Let's look at these questions. Okay, to verify the answers, remember. Now, if I have to give a shortcut for this, anytime you see two vectors forming a V shape, forming a shape that looks like a V, look like this. Anytime you see two vectors forming something that looks like V, anything that looks like V, section from you don't know the directions. Direction will show. So if I just draw something like a V shape, something like this, let's say something like this now. The direction will be there. That is like this, or one will come in, another will be leaving. The way to add two vectors together, want to find the total vectors, find the total vectors, want to add this to this now, or add this to this, or add this to this. How you do it, use the parallelogram law of vectors, which is our resultant will be equal to the square root of f1 squared plus f2 squared plus 2f1 f2 cos theta. Now, this plus will change to minus if one is entering, starting from the other one is leaving. Don't forget that. So let's start for the A question. Question A will be the resultant of question A will be equal to the square root of 2 squared plus 3 squared plus 2 times 3 cos 40 plus 40. That's what we're going to have here. So what we're going to have this. Then for B will be equal to the result will be square root of 2 squared plus 4 squared. Then remember, so if one is coming in, the other one is leaving, then this plus here, this plus, how will change to minus 2 times this other 2 here times 4 cos the other is 20. So these are going to have as the. So if you do this, you're going to have. Then the last one, question C, will be the answer. So you saw this one as a classwork. So you know as classwork. Then what will be the answer to this one if you do it as classwork? So what if you do this with your calculator, what will be the answer? If you do this with your calculator, what is going to be the answer? The calculator will be fast at of time. So let's do it and see what we're going to have. Answer this question A will be 4.7 Newton resultant. Then the result of this and this one is 4.7 Newtons. Then for vector B, for question B, result of this and this will be 2.23 Newtons. Then for this, result of this and this will be 5.97 Newtons. Please be sure you use the appropriate rule, practice it. Now next class, we're going to be looking at resolution of vectors. How to resolve vectors into the x and y coordinates using the Cartesian coordinates and so on. So don't miss that class. And please ensure you practice what we have done so far in vectors. I've done the first part, show you practice. Second part, practice. Look for questions elsewhere, then practice as well. Practice, practice, and practice. That is the key in this physics and mathematics. Practice more questions. Practice more questions. So God bless you. See you guys in our next class. See you at the top. Love you. Thank you.